So now that we've got the mass measured and the volume measured of our object, we need to figure out what's going on. So I'm just going to draw a scenario here. Here's my boat floating in the water. All right. So if my boat's floating in the water, it has a downward force of gravity and an upward buoyant force, and that's it. There's no other forces besides those. It's just the downward force of gravity, upward buoyant force. Now, this unit buoyancy is really just Newton's second law problems. It's just like you did last year, which I'm sure you all remember. But in case you forgot, F net equals ma. The way you find net force is you add all the up forces and subtract all the down forces. So the up forces are buoyant, and that's it, minus the down forces, which are gravity, equals ma. Now, because I'm floating, a is 0. So 0 times anything is 0. Let's add Fg to the other side. And we get this. Fb equals Fg. So what relationship is there between the buoyant force and the force of gravity? They are the same. And this is always true if it's floating. If you want to write this as a note to yourself, you can. So this is always true for floating. It's not always true for things that are submerged. But if something's floating, the force of gravity and the force of buoyancy are the same, always, every time, if it's floating. If it's in the water, that's not always the case. But if it's out of the water somewhat, if it's floating on the surface, then it is. All right, the boat will sink if the density of the boat equals or exceeds the density of water. Since the volume of the boat is fixed and cannot change, the only way to increase the boat's density is to change its mass. Calculate how much mass the boat can hold before it sinks. Some things to keep in mind are that the density of water is 1 times 10 to the third, and you will need to account for the mass of the boat. So let's start off with figuring out how much mass it can hold. So Fg equals mg. So we're going to say the mass of the object times 9.8. And that equals the buoyant force. Okay, so all I need to do is figure out what the buoyant force is, and I'll be able to solve for the force of gravity. So if I can figure out the buoyant force, I can figure it out there. So how do I find the buoyant force? Well, if you look at your equations at the bottom, there are two big equations for buoyant force. Fb equals mfg, and Fb equals density of fluid, mass of the object over density of the object times gravity. So this equation is obviously the easiest. If I know the mass of the fluid, then I can do this one. But be careful. It's not asking for how much fluid is in the tub of water. It's asking for how much fluid does the boat push out of the way. Right? Because if all I wanted to do is figure out the mass of the water, all I'd have to do is weigh the tub and we'd be fine. That's not what it is. It's how much water is pushed out of the way. And that is harder to measure unless you have specific apparatus to do that, which they do exist. You fill a container full of water, you have a spill-off part, you put something in it, the water spills over the edge, and it measures how much water falls over in the spill-off area. Okay, I don't have one of those, and it's hard to make one that's accurate, so we're not going to be able to do that. So we can't really do this one, at least not yet. So then we look at the other equation, and we say, oh, that is scary, scary, scary looking. Well, it's not really, though, because if we want to solve the buoyancy of if we want to solve for the buoyant force, we just need to know the mass of the object, and then the density of the fluid, which we know, the density of the object, which we can kind of know, and gravity. So the problem is we still don't know the mass of the object. And you're saying to yourself, Mr. B, you just told me two equations, and I can't use any of them. How am I supposed to do that? Well, we're actually going to do something tricky here. We're going to be too smart for physics. We're going to use this equation. And I know you're saying to yourself, Mr. B, why would I use this equation? I want to know buoyant force. Well, I really don't need to know the buoyant force. I just need to know the mass of the fluid. Because if I know the mass of the fluid, I can solve for the mass of the object easy enough. So how do I find the mass of the fluid? I find it by doing the density of the fluid equals mass of the fluid over volume of the fluid. And this is how you're going to solve your boat lab problem. You're going to use this one equation here. So, what should the density be? Well, the density of the fluid is water, so 1 times 10 to the third, or I'm just going to write it out as 1,000. The mass of the fluid that would be displaced, we don't know, but we do know what the volume of the fluid should be. Anyone want to take a guess? What do you think the volume of the fluid should be? It's on your paper. What do you think, Cole? Nope, that's a good guess, though. It's on your paper. Yes. It's 0.000756. So let's talk about why this makes sense. So why is the volume of the fluid the same as the volume of the boat? How much of the boat is underwater if I have as much weight on the boat as possible? Maybe. But if it's half and I put a little bit more on, what will happen? It'll sink more, but it'll still float. So it's not half. You guys are so awake. I love it. It's terrific.
Because you can go all the way up to the net.
It's all of it. Yeah, it's the whole. It's equal. If you push the whole thing underwater, but it hasn't sunk yet, that's how much water is pushed out of the way. The same volume. The volume of the fluid and the volume of the object will be equal to each other because we've sunk the boat as much as we can without us actually sinking. And so that's what we're going to solve for here. So let's go ahead and do this. All right? We're dividing by the volume, so we have to multiply that to the other side. So let's go ahead and multiply it over. 1,000 times 0.000756 gives me a mass of fluid to be 756. Now, these are in grams, by the way. Even though we originally started in kilograms, I went ahead, I told you we were going to think about this in terms of grams. So 756 grams, technically it's 0.756 kilograms. But we're thinking about it in terms of grams here. So, if this is the mass of the fluid pushed out of the way, how much mass of the object can I hold?
You can put like crackers in it.
Yeah, it's the same amount. This mass of the fluid is also the mass of the object. Because if the weights are the same, the masses should be the same, at least on Earth. So, this is the total amount of mass it can hold, but it has a mass of its own, 0.01875. So, all we have to do now is subtract the mass of the boat, which, by the way, is 18.75 grams. So 756 minus 18.75. I'm going to estimate that my boat can hold 737.25 grams. All right. Let's see if it does. Yes, Haven.
I can't read what's under. What's the subtraction you did?
I subtracted the mass of the boat. And the mass of the boat is 18.75 grams.